So let's start the video. So today we are going to see about the RAG, which is a retrieval augmented generation, which is basically an AI framework that improves the accuracy of large language models. Large language models are basically Chat GPT and this Grok and this DeepSeek, etc. By retrieving relevant information from an external sources. These external sources are basically in the form of PDF, CSV file, or the real-time database like SQL database before generating a response. This approach helps this large language models provide more accurate, fact-based, and up-to-date answers. Now, how it works? So, there are two components of it. One is the retrieve. This model looks for relevant information from a knowledge base, such as Wikipedia or company internal document, which is like we have discussed, like PDF file or CSV files, etc. And second is the generate. It then combines this retrieve information with its own knowledge to create a more informed and accurate response. So, what it will do? First, the retrieval portion retrieve the knowledge from the knowledge base, and then the generative portion, that is the LLMs, combines retrieve information with its own knowledge, that is the knowledge of the LLM, to create a more informed and accurate response. Now we will check this with the help of an simple example of with the help of PDF files. Here we have taken a scenario of internal company support system. This support system will basically in the form of PDF files or CSV files, and the context of this will be that a company use an internal AI chatbot to answer employees' queries about HR policy, leave balance, and project details, and the relevant information is stored in form of PDF files, or we can take SQL database for the real time information. So this PDF files here contain employee leave record, HR policies, and project data. Now here we will check about the two type of responses that we will get without retrieval augment generation and with retrieval augmented generation. Without retrieval augmented generation, we can see that how many leave days do I left this year. When the user or the employee asks this query from the LLM, then what, without the RAG system, the LLM will frame the response that the company usually provide 20 days leaves per year. Check with HR for exact detail. So it will giving out the generic and incomplete response without PDF data. Then if we will take the similar response with the RAG file, and then the user asks the query that how many leave days do I left this year, then when there will be the RAG enabled system or the RAG enabled response will be there, then then the response from the LLM is that you have 10 leave days remaining for this year. Please submit your leave request through the company portal. So here you can see the complete difference between without RAG and with RAG. Without RAG, the LLM response will be like incomplete, and with RAG, you can see here, since it has company internal data in the form of CSV files or PDF, so it will giving the accurate response. Now how we will, here we will see how basically the RAG pipeline work. So here there when we will direct upload or give the system the PDF file, then PDF file or the CSV file, then there will be a particular type of document loader which basically load this PDF or CSV file. Then there will be different type of text splitter. So text splitter, if you can see, like if you can check in different framework, like in the LangChain framework or PyData framework, there are different type of text splitter, like recursive text splitter, agentic splitter will be there, semantic splitter will be there. So what it will do, it will divide this PDF in the form of different text chunks. Then these chunks will be fed further to the embedding generation model. So this embedding generation models is also of different type, like the Olama embedding model is there, and there will be OpenAI embedding model, Hugging Face embedding model. You can see all these in the website. And then after that, what happens when these text chunks will be further fed into the embedding generation model, it will generate the embeddings. So what are basically the embeddings? The embeddings are nothing but these are actually the vectors are in the form of numbers. Since the computer system doesn't directly understand the English language, so we have to convert these text chunks or the English language in the form of vectors or the numbers. So these vectors or the numbers are basically the embeddings, and these embeddings will further store in a vector database. As like we have seen, there are different types of embeddings like Olama and embeddings, Hugging Face embedding. There is different type of vector database also. So vector database here is like so there is different type of vector database also. So vector database here is comprises of this the spine cone, chroma db, lance db. Then after that, once all this document is stored in the form of vectors or numbers in the form of vector database, then the user will give the query. This query or the question, which we call as a prompt, is also converted into embedding by the embedding generation model, and then this query embedding will found a similarity or semantic search with the vector database. That is, the response generated from the PDF file will be found a semantic similarity or semantic search with our queries, and then this query will go to the LLM along with all the chunks or response from the embedding models goes to the LLM, and finally the answer will be generated and fed to the user. So thank you. This is the complete tutorial about this.